Here we have the series 1 divided by the third root of n squared plus 4, and we want to show that this series diverges. And so to show this series diverges, we need to show that the limit of a sub n divided by b sub n is a positive number, finite positive number. And then the second step is we need to show that the series b sub n diverges. And then we can say that the series a sub n diverges. So first, we need to let a sub n be the sequence, be this sequence. And then we need to let b sub n be something similar. So we just let b sub n be the same thing but without a 4. And then notice that this is the same as, this is the third root of n to the second. And so using rational exponent, this becomes n to the 2/3. So first, we need to show that the limit is some positive number. So this will be 1 divided by the third root of n squared plus 4. And then this is 1 divided by the third root of n squared. Then we can simplify this as follows. Dividing by 1 over the third root of n squared is the same as multiplying the reciprocal. So it's going to be that dividing by this. Since the top here we have the third root and then the bottom here we have the third root, so we can combine them. Like this. And then to simplify this for the limit, before taking the limit, we can divide the top and the bottom by n squared. And this, the n squared divided by n squared is just 1. N squared divided by n squared is 1. And then we have 4 divided by n squared. This will be 1, and then as n approaches infinity, this will go to 0. So the inside here would be 1 divided by 1, which is 1, and then the third root of 1 is just 1. So what we have just shown is that the limit of a sub n divided by b sub n is 1, which is greater than 0. So we've shown this first step right here. And so we want to show that the limit of this series right here diverges. The series a sub n diverges. So next, we need to show that b sub n diverges, the series b sub n diverges, before we can say that the series a sub n diverges. this is a P series with P equal to 2/3. And since P is between 0 and 1, this sequence right here diverges. So recall that P-series test, if P is greater than 1, series converges. If P is between 0 and 1, including 1, the series diverges. And so let's review this, let's recap this. So we have shown that the limit of a sub n divided b sub n is equal to 1, which is greater than 0. And then next, we have shown that the series b sub n diverges. And so we have shown this, and then we have shown that the series b sub n diverges. Now we can say that the series a sub n diverges also. So this is the series a sub n. So we have shown that b sub n diverges, and therefore now we can say that the series a sub n diverges also.